In this video, we're going to learn about geometric series. So a geometric series is what you get when you take a geometric sequence and you add all of the terms together. So we're just going to say that a geometric series is the sum of the terms in a geometric sequence. Now, what is a geometric sequence? A geometric sequence is a list of terms where we are multiplying or dividing by the same number every time to get the next term. So if we're doing a geometric series, it's really just a sequence, but we're adding up all the terms. So an example could be 1 plus 3 plus 9 plus 27. So this is a sequence where every time I am multiplying by 3. Or I could do 256 plus 128 plus 64. So this is a sequence where I am dividing by 2 every time. So the formula for a geometric series is a little bit different from the formulas we've done before. And I'm not actually going to prove it to you because there isn't really a super easy way to do that. I'm actually going to give you the formula. So we're going to say that Sn, the sum of the first n terms, is A, the first term, times R to the power of n, take away 1. Now in all the other ones, the take away 1 would be in the exponent or with the n, but here it is not. It is separate. And that's divided by R take away 1. And I am just going to make some notes here that S stands for the sum. A is our first term. R is our common ratio, what we're multiplying by every time. And N is the number of terms. Now, if you are absolutely dying to know where that formula came from and you just don't think you can go on without knowing, I'm going to give you my 30-second proof on where that formula came from. So if you take the sum of the first n terms in a geometric sequence, the first term is always A. And then if we think about our geometric series formula, right, Tn is A times R to the n minus 1. So our last term is A times R to the n minus 1. Now, I did not come up with this. People who didn't have televisions a long time ago had nothing better to do than think about math all day long. So they came up with a lot of interesting things. So what they did was they took Sn and they multiplied it by R. So we just took all of the terms, multiplied by R. So here we ended up with A, R n minus 1, and here A times R to the n. And then they subtracted the 2. So I wrote Sn take away R times Sn equals, and then I have A, and I could do A take away AR, but I noticed that there were matching terms here and here, here and here, and it goes all the way down the line, that all of the terms match up and will subtract out, except for that A at the beginning and that AR to the power of n at the end. So here we just get Sn take away R times Sn is A, and then take away, because this is the one on the bottom, A times R to the n. Everything else has a matching one that it subtracts out with. So then what we did was we factored, took the Sn on the left out of those terms, took an A on the right out of those terms, and divided the 1 minus R to the other side to get A times 1 minus R to the n over 1 minus R. Now you'll notice that the brackets are backwards here. So what we can do is take a negative out of the top, right, which will take R to the n minus 1, switches the terms, and take a negative 1 out of the bottom, which also switches those terms, and then a negative divided by a negative just makes a positive. So I hope that helps. There you go. I will never ask you to do that on your own, so don't worry about it. So what we're going to do is practice using the formula. We're going to do 3 examples today where we take a look at how to use our brand new formula. And the first one is right here. It says determine the sum of the first 22 terms in the series 1 plus 3 plus 9 plus 27 plus ... So it's important to notice that there are 22 terms. And I need to do what I always do. I need to start by figuring out what type of series is this. Is it arithmetic? Is it geometric? So I can check for adding and subtracting first. That would be arithmetic. I notice here we're adding 2, and then we're adding 6. So obviously it's not arithmetic. It has to be the same number every time. So then what I can do is I can figure out if it's geometric. If you have trouble finding the pattern, you always take the second term divided by the first term. But I can see here that this is times 3, and this is times 3, and this is times 3. So since I'm multiplying by 3 every time, I'm going to zoom in a little here, I know that this is definitely geometric. And because I have those addition signs, I know that this is a geometric series instead of it being a sequence. I also can tell because it has the word sum, it wants me to find the sum of all of the terms. So I'm going to use my formula for the geometric sum, which is Sn equals A times r to the power of n. The minus 1 is not in the exponent, divided by r minus 1. So I'm going to list S, A, R, N, and I don't need to worry about the ones. And I'm going to fill in as much as I know. So the 22 terms, that's going to be my N. We want to know the sum of the 22 terms, so that's the number of terms. A is always our first term, and in this case the first term is 1. R should be my common ratio, so what we're multiplying by. In this case, it's going to be times 3. And the sum is what we're trying to find. So I'm going to substitute in everything I know. Now you can leave this as Sn or you can write S22. I would accept either. A in this case is 1. R is 3. N is 22. And that subtract 1 is not with the n in the exponent. It's down below. Divided by r, which is 3, take away 1. Okay, so I'm actually going to let my calculator do most of the work here. There is one thing, however, that I feel confident that I can calculate myself, and that's this number on the bottom. 3 take away 1 is 2. So I'm going to use my calculator, and I'm going to punch in everything exactly as I see it there. Except I've covered it up. Let's slide that over. So I'm going to do 1 times bracket, and then 3 to the power of 22, take away 1, make sure you didn't do it in the exponent, close bracket, and then divided by 2. If I do divide by 3 take away 1, it's not going to work out very well unless I put brackets around that, so I like to just work that number out myself. And I get this terrible looking number. So it's 1.56905298, and then I notice that there's this little 10 there. And what this is scientific notation. So what it's showing me is that the number is bigger than what my calculator can handle. So what it does is it squishes it down into a decimal times 10 to the power of 10. So that 10 there doesn't mean that the base is 10. That means that it's going to be 10 to the power of 10. So whatever number shows up here is going to be our exponent. So there are 2 ways I can write this. I can say that this is, and keep a couple of decimal places. So I could say that the sum of the first 20 terms is approximately 1.5, that would be 57 if you do 569. So times 10 to the 10, right, in scientific notation. Or what this means is you move your decimal place 10 spots to the right. So I'd go 1, 2, 3, 4, 5, 6, 7, 8, and then I could add 2 zeros, but that really isn't likely correct because probably the last 2 digits got cut off when it was a decimal. So I think I'm just going to leave it like this. Okay, so that's just in scientific notation, and that's okay because the number was too big for our calculator. So we're going to say that the sum of the first 22 digits is approximately 1.57 times 10 to the 10. So we're going to do the last 2 examples in the next part of the video.